Good day! Today we will tackle about strand sort algorithm. But first, let me introduce the presenters. We have Mr. Henrys Mark Patenio, and he will introduce us the strand sort algorithm. Next, we have Mr. Cyril John Villanueva telling us the code of the strand sort. Mr. Munchito de la Peña for the test cases, and the last presenter will be Christian Andamon for the algorithm assessment.
Good day everyone. Today we will talk about the strand sort algorithm. So what is strand sort? Strand sort is a recurring sorting algorithm that sorts items in an increasing order. It has O(n squared worst time complexity which occurs when the input list is reverse sorted. This algorithm operates by repeatedly extracting sorted subsequences from the input list until the entire list is sorted. Strand sort was inspired by other sorting algorithms like merge sort and quicksort. It aims to combine their strengths while addressing their weaknesses. Like merge sort, it recursively split the data into smaller subproblems, but it utilizes a different approach from merging. Unlike quicksort, it avoids the potential bad case of quadratic time complexity. Here are the key features of the strand sort algorithm. Recursive. It divides the input list into smaller sublists, sort them recursively, and then merge them back together. Strand based. It extracts sorted subsequence from the unsorted list and merge them with the already sorted part. Comparison based. It relies on comparing elements to determine their order. Efficient. Offers good average case and worst case time complexity of O(n log n). Here are the benefits of the strand sort algorithm. First, the algorithm is relatively easy to understand and implement compared to the other sorting algorithms with similar performance. For example, quicksort relies on partitioning the list based on the pivot element, which can be inefficient if the pivot is chosen poorly. Strand sort avoids this by first extracting already sorted subsequence, making the logic less dependent on a specific element. Efficient. It offers competitive time complexity for most cases. Strand sort is comparable to well-known sorting algorithms like merge sort and quicksort, with an average and worst time case complexity of O(n log n). This guarantees effective sorting results for the majority of distributions and size of data. Adaptive. Can adapt to different data distributions due to its strand-based approach. Strand sort can benefit from previously sorted sections of the data, in comparison with the merge sort, which securely divides the entire list into subsequence, regardless of their order. By removing and combining the pre-sorted strands, it reduces the need of pointless comparison and boosts sorting effectiveness globally.
This is the code of the strand sort algorithm. I will explain each method used in this program. So the first method is the main method. The main method initializes an array of music genres, including rock, pop, jazz, hip-hop, country, electronic, and R&B. It then prints the array before sorting. This provides the initial input for the sorting algorithm. So the next method will be the strand sort method. The strand sort method implements the strand sort algorithm. It takes the array of genres as input and returns a sorted array. The algorithm iterates through the genres, creating a sublist to store the current sorted subsequence. It adds the current genre to the sublist and checks if it's the last element or if the next genre is smaller. If either condition is true, it merges the sorted list with the sublist and updates the sorted list. It then clears the sublist for the next subsequence. This process continues until all genres are processed. Finally, it converts the sorted list to an array and returns it. Merge method. The merge method is used within the strand sort method to merge two sorted lists into a single sorted list. It takes two sorted lists as input and returns a merged sorted list. The method compares elements from both lists using two pointers and adds them to the merged list in the correct order. Any remaining elements from either list are added to the merged list. This ensures that the merged list is sorted. Array to string method. The array to string method is a helper method that converts an array to a string representation for printing purposes. It takes an array as input and returns the string representation of the array. This allows for the printing of the sorted array of genres. So this will be the output. The output shows the array before sorting and after sorting using the strand sort algorithm. The genres are sorted in ascending order based on their lexicographical order, from rock, pop, jazz, hip-hop, country, electronic, and R&B. Then after sorting, it becomes country, electronic, hip hop, jazz, pop, R&B, and rock.
Test cases. In test cases, we created some tests to identify the flow of the algorithm and different scenarios. First is random order cases. We begin with the following initial array in this example, which is random order 4, 2, 7, 1, 5, 3, and 6. Every element of the array is given a sublist by the algorithm as it iterates through it. There is only one element in each sublist because the elements are arranged in random order. The final sorted array is produced by the algorithm by combining each sublist with the sorted list 1, 2, 3, 4, 5, 6, and 7. Next is reverse order case. In this case, we begin with the following initial array which is in reverse order 7, 6, 5, 4, 3, 2, and 1. Every element of the array is given a sublist by the algorithm as it iterates through it. There is only one element in each sublist because the elements are arranged in reverse order. The final sorted array is produced by the algorithm by combining each sublist with the sorted list 1, 2, 3, 4, 5, 6, and 7. So last is the duplicate order case. So we begin with the following initial array in this example, which contains duplicate elements 4, 2, 7, 1, 5, 3, 6, 2, 7. Every element of the array is given a sublist by the algorithm as it iterates through it. There are instances of every element in the sublist. The final sorted array is produced by the algorithm by combining each sublist with the sorted list 1, 2, 2, 3, 4, 5, 6, 7, and 7.
For the algorithm assessment, the performance evaluation for strand sort had an easy-to-understand sorting algorithm. It might not be the best option in terms of computing efficiency and memory usage compared to other sorting algorithms that work in place. Strand sort may take more memory since it needs additional linked lists to hold the sorted sublists. Strand sort's worst-case time complexity of O(n squared) might be a major disadvantage for big or unsorted lists in terms of computational efficiency. Generally, other sorting algorithms like lower average case time complexity are quicksort and merge sort. Moreover, graph traversal and pathfinding tasks are not intended uses for strand sort. It is mostly employed for list element sorting. Other algorithms like Dijkstra's algorithms or the A algorithm would be better suited if pathfinding efficiency is needed. Evaluation methods. Even though strand sort is effective for partially sorted data, in many situations it may not perform as well as the other sorting algorithms. Quicksort, merge sort, and heap sort are examples of algorithms that are more adaptable to different input distributions and typically provide better average case time complexity. Furthermore, for particular data types or ranges, algorithms such as counting sort or radix sort can perform better than strand sort. Results. Strand sort is easy to understand and implement. It may not be the most efficient choice in terms of memory utilization, computational efficiency, or pathfinding tasks, but strand sort excels in scenarios where the input list is partially or nearly sorted. In such cases, it exhibits adaptive behavior and can approach a time complexity of O(n log n), make it more efficient than other sorting algorithms. It is important to consider that specific requirements and characteristics of the problem at hand when selecting an appropriate algorithm. That is all for the strand sort algorithm. Thank you for listening.